if its cosine is a negative 1/2. So its cosine is a negative number. Any ideas where I might draw it?
Or fourth quadrant.
Sarah? One option is the third quadrant. The other option is the second quadrant. There are actually two angles out there that have a negative cosine. Now here's what I want you to think about, you guys. Cosine. Which letter, X or Y, is cosine associated with? X. Cosine is X over R. Where is X a negative number? Over here, right? This is where X is negative. So the cosine would be negative 1/2. Right? Let's see, that's a 1, that's a 2. What would this side be? √3? How big would this angle be? I'm just looking at the top triangle right now. I'll get the bottom one in a minute. That would be a 60. Now, so with this is the same exact triangle. It's just down in quadrant 3. So your answers, remember, you start measuring here. So there is one answer to the problem, and here is the other answer to the problem. You're working it backwards from the quiz you took with your partners. There, I gave you the angle, and you found the fraction. Now I'm giving you the fraction, and you're finding the angle. Only there's two of them. What's the purple one? How big would that purple angle be? 120. So one of your angles is 120. How about the green one? How big is the green one? 240. Those are the answers to the question. Those are the two angles that have a cosine that's negative 1/2. All right, let's see if you do, let's jump down to D because it's no calculator also. It says the cosecant, the cosecant is 2. Now, I don't think very well in cosecants. So if the cosecant is 2, the sine must be 1/2. Right? They're reciprocals of each other? Now, where will that be? That the sine would be a positive number. Quadrant 1 for sure. Everything is positive in quadrant 1. There's one more though. There's always two answers to these. It's quadrant 2. Why is the sine also positive in quadrant 2? Sine is y, and y is positive in quadrant 1 and quadrant 2. Now, that's a 1, that's a 2. This would be a √3. How big is the angle this time? 30. And so is this one. They always match. You're never going to have two different sized triangles in the same problem. So the answers, remember, you got to start measuring here. So one of your answers is actually 30 this time. And then how big would the other one be? It's going all the way over to here. So how big would he be? 150. Now, what changes when I have to use a calculator, which I do for problems B and C? Kids, nothing changes. Nothing. Okay? Except I need a calculator. So, problem B says the sine is 1/3. Annie?
How do you know what angles you look for on the ones on the calculator?
Same way. The sine is a positive number. So I know I'm in quadrant 1 or quadrant 2. That's where sine or y is positive.
Why do you look for when you're solving for x, why are you looking for the how do you know which angles you saw?
When you draw your butterfly bow tie, these are the angles. Those are the angles. So that angle is 30 degrees, and this one is 150 degrees. Now, if I tried to label this, the sine is 1/3, I don't know those ratios. I need a calculator. So what I do on my calculator, this is not on your quiz, we're doing this to get it done, it will be on your test in January. What I do to get that angle is second sine 1/3. Now, the answer you get is going to depend on whether you are in degrees or radians. We've been answering in degrees, so if we keep consistent, if we answer in degrees, then I want my calculator set in degrees. And the angle turns out to be about 19.5. So again, press second sine 1/3. And it should say 19.5. Unless you're in radians, then it says point something.
Which one are we on?
Number 2, or B.
B.
B, yep. Now, what are the answers to the question then? There are 2 angles. This one right here, which would be 19.5. And this one right here, which would be 180 minus 19.5, which is what? 160. All right, let's do one more of those. See if it's starting to make any sense at all. The tangent is 4/5. All right. First thing you do is stop a minute and say, all right, I need my tangent to be a positive number. I'm going to draw 2 triangles, and the tangent's going to be positive. So somebody said 1. Clearly, the tangent is positive in 1. Everything's positive in 1, right? There's no negatives in 1. Where else would the tangent be positive? 3. Why 3? You are exactly right. Because tangent is opposite over adjacent, or y over x, and in quadrant 3 they're both negative. So when you put one over the other one, you get a positive. Oh my gosh, you have to think about this. Now, I have no idea what that angle is. It's not special. So I'll second tangent 4/5. And it says it's about 38.7 degrees. So what are the answers to the question? Now I got a picture. X is going to be 38.7. And then here's the other one. So I got to go all the way around to here. So what will that be? 218.7. Now, what you absolutely need to come away from that keeping in mind is sine and cosine and tangent are positive and negative in different places. And you got to be able to figure out where they're positive and negative. All right, number 2, y equals cotangent x. Hopefully you remember it looks like this. Number 2. I'm just going in order because we got to do this. Got to turn this in. Domain. Now, be careful. It's a little bit confusing when I only, or misleading is a better word, when I only draw one period. Remember, this thing does keep going forever and ever and ever. It keeps going. There's tons of them. We just normally look at this one piece. So what's the domain? It keeps going forever and ever and ever. You're tempted to say all real numbers, but how about here? What are these guys doing? What are these guys doing? They're breaking it up, right? So your domain is all x's except the multiples of pi. Because that's an n, yeah. What happens every time you have 0 pi, 1 pi, 2 pi? What happens? We have an asymptote. Asymptotes are undefined. They don't exist there. So the tangent, or cotangent, does not have a domain of all real numbers. It's everything except the multiples of pi. And if that notation bothers you, you could write all numbers except the multiples of pi. You could write that out. Or say except 0 pi, 1 pi, 2 pi, 3 pi, dot.
Wait, on the sheet it says it's a cosine, not a cotangent.
Oh,
Oh, sorry, I'm on 3 already, sorry.
okay. You're ahead of me. I'm still on 2. All right, what's the range? Now the range is going up and down. The range is all real numbers. The range is all real numbers. Would you say the cotangent is continuous? No, because what happens when I draw it? What do I have to do? I have to keep picking up my pencil. It's not continuous. Would you say it is increasing or decreasing? It's a decreasing function. That's exactly right. Every piece that you draw is going down. Does it have any asymptotes? Yes. Every multiple of pi. 0 pi, 1 pi, 2 pi, 3 pi, those are the asymptotes. Would you say it's bounded? Bounded means ceiling and floor, guys. We have a ceiling and floor? No. Extrema, high points and low points? No, none of those. All right, now I'm going to sketch one period of these. Now, on your quiz, you will not be sketching, but you will be listing period, amplitude, vertical shift, and phase shift. So let's see if we can get a period of this sketch. It's a cosine, pretty simple. Okay, so here's what I'm doing. I'm thinking in my mind cosine. Top of hill, top of hill. That's what cosine looks like. Has this one been turned upside down? Nope. Has it been shifted sideways at all?
Yes.
Shifted sideways at all? No. The only way you're going to have a shift, kids, is if what do you have in the problem? Pluses and minuses. Right. I don't have any adds or subtracts. So this cosine is a normal looking cosine. It starts here, stops here, just like every other normal cosine does. Now, its amplitude is 2, right? And its period, which normally is 2 pi, has been changed. What have I done to the period? Divided it by 2, so this is pi. So the period is pi. It got scrunched. What's the halfway point then? Pi over 2, or some of you write 1/2 pi, that's fine. Pi over 2, 1/2 pi. What's this one? Pi over 4, or 1/4 pi. What's this one? 3/4 pi, 3 pi over 4, 3/4 pi, and we're done. Amplitude.
The frequency, is that the...
We haven't talked about frequency yet, it's reciprocal of the period. We'll talk about that after Christmas. Amplitude is 2, period is pi, vertical shift is 0, there's no like plus number here, and horizontal shift or phase shift is 0, didn't move it anyway, sideways. Alright, let's see if we can get these last 2 graphs done. Oh, B is easy. B is a regular tangent curve. B is a regular tangent curve, except what? It's flipped. So, everything about it is the same. Its asymptotes are where they are normally. Miss Ford, how do you know that's where they are? I memorized it when I was supposed to. Goes through the origin. But a normal tangent increases. When I turn it upside down, it's going to decrease. So it's going to have the shape of a cotangent. But it's going to have the asymptotes of a tangent. Upside down. Amplitude. What's the amplitude? None. No amplitude. The only things that have amplitude are sine and cosine. What's the period? Pi. Haven't changed it. It's pi. Here to here is pi. Any phase shift or vertical shift? Nope. None of that. 1/3 cosecant plus 1. Now pay attention. Where is the plus 1? On the end. So that means it's going to be a vertical, right? So I'm going to focus right here. And who remembers Friday how we talked about doing a cosecant? Make it a sine. So I'm going to pretend for a minute that's a sine. It's just a regular old sine whose amplitude is 1/3. Have I done any changing of the period? No. So the period's 2 pi, which means that's pi, and that's a half, and that's 3 halves. Just a regular sine curve. I haven't changed a single thing about it, except it's only 1/3 tall. That's the sine. Now, who remembers how we get to a cosecant from there? Well, I flip it, but not until I do what? I got to do something else. I've got to put in my asymptotes. And where do the asymptotes go? Wherever we cross the x-axis. Then I flip it up and down. I'll erase this guy. That's my cosecant. But I'm not done, am I? I gotta move it up 1. Okay, now watch it. This was 1/3, 2/3, 3/3, 4/3. So I gotta move it all the way up there. So there's that one. And this is at -1/3, so he's coming all the way up here. There he is. So the green thing is the answer. Amplitude. None. Period. 2 pi. Phase shift, horizontal shift. 0, but vertical shift is +1. All right, we will finish this sheet tomorrow. Wednesday we have.
Wednesday we have all the periods.
Okay. All right. Well, we'll take our quiz and then finish this if we have time. Maggie, would you turn that off and hand it to me, please?